So when we look at equations, I'm actually going to go down here a little bit. This is our excursion through equations, and sort of identify. We went through this when we did the demo days, but we have synthesis, which is basically A plus B gives me C, two things coming together and making one. We have decomposition, which is C going back to A and B. And again, they don't have to be elements, they can just be compounds, they're just breaking apart. We have single replacement or displacement, depending on which, they go by both names, where you have A, B plus C gives A, whoops, try again, gives CB plus A, or A, B plus D, giving A, D plus B. So either the girl can get kicked out or the guy can get kicked out. And I call the girl the negative and the guy the positive. We also have double displacement or replacement. This is where you have AB plus CD going to AD plus CB. So I switch partners. A kind of double displacement is an acid base. And that is when you have a hydrogen with something plus something with an OH, giving water plus something else that we usually call a salt. And then we have combustion, which is some carbon compound, usually. There are sometimes we use sulfur compounds or nitrogen compounds, plus oxygen, giving us CO2 plus water. Now this right here, CO2 can change if it's not a carbon compound. If it's a nitrogen compound, it will be a nitrous oxide. If it's a sulfur compound, it will be a sulfur compound, sulfur oxide. So these are what we're trying to identify. So if we go back up to the top, did I give you enough time to write that down? Okay, go ahead and take a few minutes. I'm going to pause the video. Okay, so we're going back up top. Okay, so let's look at these. As we're looking at these, let's see if we can identify what they are. Here I have a compound and a compound yielding new compound, new compound. What type? Double displacement. Now I have a compound and a compound making a new compound and water. What type? Acid base. Acid base, because it's a double displacement, but it made water. Here I have a carbon compound plus oxygen giving me carbon dioxide and water. Combustion, yeah. Here I have an element plus a compound giving a new compound, new element. Single displacement. Only one thing got displaced. Here I have a compound breaking down. Decomposition, I heard it underneath your breath. Okay, here I have two elements making a compound. Synthesis. Here I have a compound and a compound, new compound, new compound. Double displacement. Here I have a compound and an element, compound, element. Single displacement. Here I have a carbon compound, oxygen, carbon dioxide, and water. Combustion. Here I have a compound and an element, give me a new compound. Synthesis, I'm putting them together, synthesizing. Here I have a compound element, an oxide, and an element. Single displacement, good. I have a compound and compound, a new compound, new compound. Double displacement. I have a compound going to two elements. Opposite of synthesis. Decomposition, it's falling apart. I have one thing falling apart. Decomposition. Okay, so let's look at the next one, section 2. So I'm looking at section 2 on this one. I'm not going to be able to fit all of them on here. I'll do most of them with you, but not all. Okay, we are going to balance this as well as tell the type. So I'm going to enlarge this. I'm also going to grab myself a scratch piece of paper because when I balance things, I want to be able to use a scratch piece of paper. I like to bring my scratch piece of paper and I put it here. So if you got a scratch piece of paper, it might not be a bad idea. Now, we can look at this one and is what type of reaction. We can do that up first. Combustion, good. Compound plus oxygen yields water and carbon dioxide. Now we need to balance it. Make it the same on both sides. So underneath the arrow on my scratch piece of paper, I write carbon, hydrogen, and oxygen. I always leave hydrogen and oxygen to very last. So ho, 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 he gets the last word, okay? So I have 6 carbons on the left. I have 1 carbon on the right. So I put a 6, and that makes 6. On the left, I have 6 hydrogens. On the right, I only have 2. So I need to put a 3 in front because 3 times 2 is 6, and I now have 6. For the oxygens, I have 2 on the left. I have 3 plus 6 times 2, which is 12, giving me a total of 15 oxygens. How can I get 15 when I can only get even numbers on the left side? Well, I've got to use a little trick. I put 15 halves there just for a minute, and that will give me 15, right? But I can't leave a fraction there. How do I get rid of a fraction in math? Multiply by the bottom number, right? So I'm going to multiply by the bottom number all the way through. So 2, 15 halves times 2 is 15. 3 times 2 is 6. 2 times 6 is 12. And I've got my balanced equation. Okay. Then I'm going to move to another piece on my sheet, and I'm going to move my sheet down to the next one. Okay. Again, I look at it and say, okay, compound, compound, new compound, new compound. What type? Double displacement. And underneath the arrow, I put Na, I, Pb, S, and O. On the left, I have 1 sodium. On the right, I have 2. So I'm going to put a 2 over here. By the way, I wouldn't do this in pen. I would do it in pencil because you'll see in a minute why. So I now have 2. I now have 2 iodines on the left, but I have 4 on the right. So now I've got to go back, erase that, and put a 4 here, which will change both this and this. So now I got to go back and fix my sodiums on my right by putting a 2 here, and everything's still balanced. Okay? Then I go to my lead, 1, 1. My sulfurs, 2, 2. My oxygens, 8 and 8. Good. Okay. Erasing. Actually just moving to another piece of my scratch paper. On the right side, the 2 goes through. Okay. Moving down to the next one. What type of reaction would this be? This one's a tricky one. It is a combustion. Okay, why would it be a combustion? I've got a plus O2 and it ends with water, and I've got an oxide, a nitrogen oxide, sulfur oxide, carbon dioxide, something like that. So this is a combustion. So I've got nitrogen, hydrogen, and oxygen. I have 1 nitrogen on the left and 1 on the right. I have 3 hydrogens on the left and 2 hydrogens on the right. Common factor of what? 6. So I'm going to have to times this one by 2, which affects this and this. And I'm going to put a 3 in front of this one, which only affects this one right now. So I've got to go back and fix my nitrogens. So I'll put a 2 here to fix the nitrogens, and we're okay. Everybody okay? Now I got to do my oxygens. I have 2 on the left. I have 2 plus 3 gives me 5. I'm going to use my little trick again. I'm going to times this side by 5 halves, so I can get 5. But that only helps me for a second because I've got to go back through and times everything by 2. Okay, so I got that. I'm going to erase my excess stuff now. I would just use my scratch paper though and move it to a new place. Move it down 1. So what type do I have here? No? You got a water, but you started with one thing and it fell apart.
Oh, decomposition.
Decomposition, good. Started with one thing and you really want that acid base. Okay, so we have an F, E, H, and O. Remember always to end in ho, ho, ho. So we've got 1 iron on the left, 2 irons on the right. I'll put a 2 in front of this one to make them even. Now I look at my hydrogens. On the left, I've got 2 times 3, which is 6. On the right, I only have 2. So I'm going to put a 3 in front of it and make it 6. Okay, on the left, I now have 2 times 3 oxygens, which is 6. On the right, I have 3 plus another 3, giving me 6. It is balanced. Everybody follow that? Yep. You don't put 1s in. Never put 1s. Okay? So, again, I'd move to another spot on my scratch paper. And what type is this one? Acid base. She was waiting for it. She was waiting. Okay. So, on this one, we're going to go nitrogen, magnesium, hydrogen, and oxygen. So going through, nitrogen, 1 on the left, 2 on the right. So I'm going to put a 2 in front of this. Magnesium, 1 on the left, 1 on the right. Hydrogen, I've got 2 plus 2 more, giving me 4 on the left. And I only have 2 on the right, so I'm going to have to put a 2 to get 4. Hopefully my oxygens have worked out. I have got 6 plus 2, giving me 8 on the left, and 2 plus 6, giving me 8 on the right. So I've got it balanced. Everybody okay? All right, so again, I'd move to a new place on my scratch paper. And moving down 1. What type? Double displacement, good. Double displacement is a very common one. So again, putting in here what's on both sides, leaving ho, ho, ho till very last. So we got 1 phosphorus on the left, 1 on the right, 1 sodium on the left, 3 on the right. So that's when I stop and say, okay, I've got to put a 3 right here. Now I've got 3 bromines, and I only have 1 bromine, so I'm going to put a 3 here. Then my hydrogen on the left is 3, hydrogen on the right is 3, my oxygen on the left is 4, my oxygen on the right is 4. Good? Everybody following? Okay, again, I would move down, erase my stuff. Okay, what type is this? Synthesis, good. So synthesis, and I've got just carbon and hydrogen. So I've got 1 carbon, 3 carbons, put a 3. I've got 2 hydrogens, A hydrogens, put a 4. We're done. Some of them you can do without writing down. The more difficult ones you'll want to make sure you write down. Okay, what type is this one? Double displacement, DD. Okay, CaMnIO. So 1 calcium, 1 magnesium, or manganese, 1 manganese, 4 iodine, 2 iodine. That's where I have to stop. I have to put a 2 in front of that, which makes that 4, but also changes that to a 2. So I go back over here on the left side and I put a 2, and I haven't messed with the oxygen yet, so I'm okay. So now the oxygen, 2 and 2, and I'm done. Okay? Moving to a new place on my scratch paper. What type? Synthesis, good. So then I'm going to have Fe, H, and O. We have 2 Fe on the left, 1 on the right, a 2. We have 2 hydrogens on the left. We have 2 times 3 is 6 hydrogens on the right. I'm going to put a 3 here. On the left, I have 3 oxygens plus another 3 oxygens, giving me 6. On the right, I have 2 times 3, which is 6. Okay, and one last one, I think, is what we can see all the way. Okay, what type is this? I'm actually going to get this off because I'm tired of looking so high up. I'm going to move it down. Ah, much better. My neck is gone. Okay, so this is a synthesis, good. And we have just carbon and hydrogen. So we have 2 carbons, 2 carbons. Over here we have 2 plus 2, giving me 4 carbons. Over here we have, whoops, it shouldn't be equal. Over here we have 8. That is an 8, right? It's not a 6. Is it a 6? The way it projects, I wasn't sure. Okay, we have a 6. I don't want to mess with this first one, okay, because if I mess with that, it messes up my carbons. But I can mess with this one, right? If I put a 2 in front of this, that makes that a 4, and 4 plus 2 is 6. Okay, let's go on to the next section. Next section. So I'm not going to necessarily do all of these with you, but I'm going to do some of each kind. So the next section here, you're actually given, all the words, all the chemical equation in words. So you have to actually write it, balance the compounds, and then balance the reaction. So silver is Ag. It's a +1. That's what the Roman numeral tells me. Nitrate, NO3 with a minus. +1, -1, smash them together. Plus hydrogen, H+, sulfide, S2 minus. Okay, I'm going to need 2 hydrogens with 1 sulfur. Gives arrow. Silver 1, Ag plus sulfide, S2 minus. So I'm going to need 2 silvers to go with the sulfide. Plus nitric acid. Acid means I have an H+. Nitric came from nitrate, which is NO3 minus. So it's just going to be HNO3. So now I've got it written, not balanced. I can tell what type it is, which is what? Double displacement. Good. Okay, is it balanced side to side? I'm making you do it without the paper, but you can use the paper if you want to. This one is not that hard. What's not balanced? Let's go there. What's not balanced side to side? Silver. So let's put a 2 in front of the silver. Now what's not balanced? The N's not. So if I put a 2 right here, the N is balanced now. The H is also balanced, right? And the S is balanced. So we're good. So going down to the next one, I'm actually going to grab a smaller pen. There we go. So 10 is SN, and it's just the element. Plus copper plus 2, so Cu plus 2. Sulfate is SO4 with -2. Plus 2 minus 2, smash them together. Gives arrow. Tin is plus 2. We already know sulfate's a minus 2, so SnSO4 plus copper. Got kicked out. What type is it? Single displacement. And since it was all plus 2, minus 2, they are balanced. Let's look at the next one. Calcium, that's just an element, Ca, plus iodine. Now, iodine is one of our Braunhifkel, which is the diatomics of the twins. So it's iodine, Braunhifkel. So it's going to be I2. So that's why we need to remember Braunhifkel or the twins. Gives calcium's in the second column. It is going to be a plus 2. Iodine's 1 away from being a noble gas. It'll be a minus 1. So we're going to need, with 1 calcium, 2 iodines. It's not because it's a 2 here on the other side where it was a diatomic. That's not the reason the 2's over there, but to balance the charge. Okay, and it is balanced. What type is it? Synthesis. Good. Okay, going on to the next one. Propane, they gave us as C3H8 plus oxygen. Oxygen is also a Braunhifkel or twin. I know I'm saying Braunhifkel a lot, but remember, those are the elements, and you just need to remember they all go in pairs. Okay, so that's what Braunhifkel is. Those are the diatomics. This gives carbon dioxide plus water. What type? Combustion, and this is one we're going to have to balance. We have 3 carbons on the left, 1 carbon on the right, put a 3. We have 8 carbons on the left, only 2 on the right, so we put a 4. We have 2 oxygens on the left. We have 3 times 2, which is 6 oxygens, plus another 4, which would give us 10. So I can just put a 5 in front of this one. This one's not one I don't have to use the half. Okay, sodium carbonate. Sodium is Na, and it's a plus 1. Let me grab a different color. And carbonate is CO3, and it's a minus 2. So I'm going to have to write Na2CO3 plus sulfuric acid. They were nice and gave that to us, but we could figure it out because sulfuric comes from sulfate, and acid means I'm mixing it with hydrogen. Gives sodium sulfate, and sodium's a plus 1, sulfate's a minus 2, so I'm going to need 2 sodiums with the sulfate plus carbon dioxide and water. Now these 2 actually came from a decomposition of H2CO3, which is carbonic acid. So there's 2 things happening here. The first was just a double displacement, and then a decomposition. So we've got a DD and a D going on. The last one here, lithium oxide. Lithium is Li with a plus 1. Oxide is oxygen with minus 2. So we're just going to go Li2O plus water. We all know that, H2O, gives lithium, and hydroxide is an OH minus, so LiOH. What type of reaction is this one? Synthesis. Okay, is it balanced? No, you need to put a 2 here and then it will be. Okay, let's go on to type 4, section 4. Now I didn't do all of them on that one with you, but I gave you some examples to go from. Okay, this is section 4. In section 4, I've now not given you the product side. So we've got to figure out the product side. How many of you are familiar with FOIL in math? Okay, we do something similar in chemistry, but instead we drop the F and the L and just go oi. Outsides and insides. Okay, so we'll get to that. Most of that happens when we're doing double displacement. So this first one is not a double displacement. What is it? It's an element plus a compound, which would be what? Single displacement. Good. So what we have to do with this now is we have to identify the charges. So copper, for the most part, is going to take a +2. It will take some +1, but it's most common as a +2. Silver is a +1, and sulfate as a group is a -2. Now, these are two guys fighting over a girl, and silver's going to lose. So silver gets kicked out by itself, and copper gets the girl. Okay? And I go back and I erase my charges because I can't keep them on there, because otherwise my equation is bad. And I go back to balancing. What do I need to do to balance this equation? Just one thing. 2 in front of the silver. Good. And it's ready to roll. Okay, now this next one is right where OI comes into play. So this is a double displacement. And go through and assign the charges. So +2 and -1. You're just looking at the charge for one chlorine, not both of them. The Cl2 there was to balance the charge on the calcium. Now remember, OI, outsides are going to go together and insides are going to go together. So we always write the positive first. So Na and Cl, +1, -1, I don't need any subscripts. Plus insides, calcium is a positive, iodine is a negative, +2, -1, so I need 2 of them. Okay, then I erase my little help and I go to balancing. What do I need to do to balance? Both NAs, right? Good. Okay, next one down. O2 plus H2. No. Synthesis. Putting it together, guys. Synthesis. O2 and H2 are going to make H2O, water. Is it balanced? No, what do you need to do to balance it? I need to put 2 here, right? And 2 there. Okay, next one. I've got a +1 for hydrogen. NO3 is a -1. Mn I don't know. OH I do know is a -1. That means Mn, since I have 2 OH minuses, has got to be a +2. I'm going to go outsides and insides again. Outsides, H and OH always make water. H and OH always make water, and whenever I split water up, I split it up, HOH. Okay? And manganese is going to go with nitrate. Manganese is a +2, nitrate is a -1, so I'm going to need 2 nitrates to balance it out. Then I can go back and erase all my fun stuff. Okay, what type of reaction? Acid base, because I made water. It was a double displacement, but I made water. Okay, so here's another double displacement because we have 2 compounds. I'm going to go through again and identify the charges. And I'm going to go outsides together and then insides together. Okay, Ag is going to go with SO4. Ag is a +1, SO4 is a -2, so I need 2 Ags. Plus the insides, barium is a +2, and nitrite is a -1, and I need 2 of them. Going back in, whoa, erasing. I can then see really quickly, what do I need to put a 2 in front of? AgNO2. Yep. Okay, next one down, what type? Double displacement again. Okay, H is a +1. Cn, which is cyanide, is a -1. SO4 is a -2. That means copper has to be a +2. H is going to go with SO4. Cu is going to go with Cn. So outsides, H and SO4. H is a +1. SO4 is a -2. I need two H's. Plus, copper is a +2. Cyanide's a -1. So copper is going to go with two cyanides. Erasing my help again and moving the board. We can look real quickly, and what do I need two of? HCN. Okay, here is a tricky one. This is a double displacement, but whenever I split water, it's got to be HOH is how I split it. So it's a +1 and a -1. So H is going to go with the I, which is minus, and Ag is a plus, and Ag is going to go with the OH. So we get our unfriendly friendly acid that will tell us hi and then eat us alive. And we get AgOH. Since they're all +1, -1, they just switched partners. And I don't need to worry about balancing them, but I do need to erase my help. Okay, what's the next one? It's a type of double displacement. It is acid-base. So again, +1, -1 for nitrite this time. And OH is a -1. I've got three of them, so iron is a +3. We're going to go outsides together and insides together. H and OH always make water. Plus, Fe is a +3, and NO3 is a -1. So I need three of the NO3s to balance the charge. Going and erasing. This one, I notice really quickly that I need three nitrogens. So I'm going to put a 3 right here. My Fe's are balanced, so then I go to my hydrogens. On the left, I have 3 here and 3 here, making a total of 6 on the left. So I need 6 on the right. I have 2. So I'm going to put a 3 here. Double checking the oxygen. 3 times 3 is 9, plus another 3 is 12. On the right, 3 plus 3 times 3 is 9, which is 12. Okay, do 2 more and then we'll set you free. So what is this type? Couple and couple. Double displacement. So +1, -1, -1, and this has to be a +2. Potassium is going to go with the hydroxide, magnesium with the chlorine. So KOH, +1, -1, don't need anything else. Magnesium is going with the chlorine. Magnesium is a +2, chlorine is a -1, so I need 2 of them. Erase my help. I notice really quickly I need 2 chlorines. I only have 1 on the left, so I'm going to put a 2. That gives me 2 potassiums. I need 2 on the right. That gives me 2 hydroxides. I have 2 on the left. I'm done. Okay, last one. What type is it? Come on, it's your favorite. Acid base. Which I know right away, since it's acid base, I'm going to make water, but we'll go through this. Plus for the potassium, negative for the hydroxide, plus for the hydrogen, and the sulfate is a -2. So outsides are going to go together and insides are going to go together. The outsides make potassium and sulfate go together, potassium being a +1, sulfate being a -2, so I need 2. Plus H and OH on the inside make water, H2O. Erasing this. I can see real quickly my potassiums are not equal, so I need to put a 2 in front of that. My sulfurs are equal. Then I go to my hydrogens. On my left, I have 4 hydrogens, 2 with the KOH and 2 with the H2SO4. So I need 4 on the right. So I put a 2 in front of that. Double checking my oxygens. I've got 6 on the right and I've got 6 on the left, so we're good. Okay, I did leave you a few extras so that if you are struggling, you can try it and come up and show me and see, or you can come up and work with me one-on-one. Okay? Questions? Uh-huh.